Okay, so today we're going to learn about post order. Post order is a little bit different from pre-order. Well, post order, where is it useful, right? Post order, we can use it for deleting nodes, basically trees, binary trees, right? It's more efficient that way. So let's look at the concept right here on the PowerPoint. As you can see, just like pre-order, we will store uh, the root, basically 1 on the stack, and traverse from left to right, and then push it on the stack that way. So first we're going to unshift 1 on the stack. So when we unshift things, we add numbers or data at the front. Unlike push will be appending number or data from behind, right? And that's what it looks like on the array or list. But in real, and then when we pop it, it will we pop it from the last in first out, right? So in this case, we push it on the stack, and then we unshift it on answers. This post order answers. Okay, so when we unshift this, 1 will be unshifted here, and then after that, 3 is the last one that we push it on the stack, right? So that's the last one. So we have to pop it out and we unshift it on the answers, and 3 is the second one, 6, and then after that we check the left and the right. So 6 is the last one that we're going to we push it on the stack and then unshift it again on the answers here, and then we go back to 5, right? So as you can see, it's kind of like a reverse way, right? So the arrow is showing like, hey, it's going this way, but that's what basically post order is, right? It's showing that, hey, the number is going from leftmost to the root, right? From the leftmost to the root, and thus recursive functions do that, right? But in this case, we are looking at traversing using iterative way, right? So that's how we're going to manipulate binary tree in a post order manner. Okay, so let's code this on JavaScript, and we will understand better in the code. Let's make sense this on the code. Okay, so this, we will type this dot post order, and we will have a function right here, and now equal to this dot root. So that will be the default if nothing passed. So let's create a stack here, and we will have answer, and then we will return answer right here. Okay, and then check if no is empty or not. If it's empty, then we're going to return null, indicating that the binary tree is empty, right? So just like pre-order, we will have to push on the stack, basically no. If it's not empty, we will push it, and then while stack length is greater than 0, then we will traverse it. Okay, so we will pop it on, we have to pop stack, have to pop the value on the nodes, and then we will have to check if and once we pop, we will have to unshift, right? Unshift on the answer. Okay, that will be a value right here, and this is what they look like, unshifting, and we will check if the left is empty. So if it's not empty, then we will have to stack dot push, and that will be node dot left. Okay, so that will be the first one, and the left, and then after that we will have to do the right. No, right. Okay, so that will be our answer. And yeah, so as you can see, we will pop it and unshift it on the stack. Check the left, check the right. If they are not empty, push it on the stack, right? And after that, we pop it again. So just like we did, we use the concept. Okay, so control and enter. If this is going to work, then it will pass, right? Control and enter, and it works. So as you can see, everything worked, and this is for depth first search, pre-order, post-order, and in order. And that's it for the solution for depth first search.